Hello. This is a map of Eastern Ontario. The red lines are Prescott-Russell, the municipalities of Prescott-Russell that I've added myself. This is a physiographic map, so every color is a different type of soil that was deposited at a different time. So we can go in chronological order, I guess. We can start with the light pink, like you see at the north. So this is on the Quebec side. Those are the Laurentian Mountains and the Canadian Shield. This is Precambrian rock. And then we have the bright pink on the Ontario side, which is Ordovician rock. So Cambrian is Precambrian, Cambrian, and then it's Paleozoic. So this is Paleozoic rock, but Ordovician is the first sequence in Paleozoic times. So we got a bit of exposure here and there, a lot of it in Ottawa. So right here at the point of the Gatineau Park, this is in Ottawa. Yeah, and then that's for the rocks, and everything else is glacial or post-glacial. So the first thing we have are the orange eskers right here, here. There's one here. Where else? There are tiny bits here and there. There's one here, close to Maxville. So those are ancient riverbeds that were deposited underneath the glaciers. So rivers flowing underneath the glaciers. And yeah, those are the glacial elements. And after that, you have the till. So we got three different types of till. You got three different types of green. So it's light green, just is normal till, basic till. We got the bright green, which is hummocky till, which means that water has been seeping through it or on it for a really long time, usually in a depression. So they form depressions, they form holes, which cause a lot of water logging. And then we've got drumlins. So here, just south of Russell in the Castro River region, got a lot of till. Drumlins, which is formed when the ice retreats, and as it retreats, it leaves big piles of rubble, boulders, rocks that it's brought with it. So it's because of the ice retreating in all one direction, all the drumlins all facing the same direction, and that's also causing a lot of water logging and a lot of swamps, wetlands. That more or less gives the Castro River its name, beaver in French. So after the till, we've got sandy deposits. We've got a bunch of different types of sand. So we got the bright blue, and then we got the baby blue, I think. Yeah, no, baby blue's that. Bright blue, and then another type of blue. Right here. So these are two different types of sand that were formed by wind and wave action. So these indicate that they would have been in shallow water and protruding from the water for it to have be influenced by wind action. So we've got some here, which is if you know the area, highest elevation point, which is near Maxville. We've got some where the Ottawa airport is, so another high elevation point right here, which would have been a beach on the Champlain Sea right here. And then we've got one here, and then going further south in the South Nation watershed, all the way, almost all the way towards the St. Lawrence. So those would have been the beaches of the Champlain Sea. After those, we see deltaic deposits. So sand that was not deposited by wave or wind, but that was deposited by the current of mostly the Ottawa River. Once the Ottawa River drained the Georgian Bay, Lake Huron, and Lake Superior from the French River, Nipissing Lake, and then Mattawa River, and then the Ottawa River. So there would have been a huge flow of water, really. And the yellow that we see is more or less the deltaic deposit, the sandy deposit, the ridges that were formed because of this strong current of the Ottawa River. So we see the yellow right here. That would have been caused by the current. This is the Prescott-Russell sand plains. So here the longest is from Ottawa. So right here, starting in Ottawa, just south of the Mer Bleue bog. If you've ever been to the walkway, right here. And this starts right here and then goes all the way, is very, very long, all the way to between Van Cleek Hill and Hawkesbury. So this is the main sand ridge. So you got the La Rose Forest right here. And you also got the sandy islands that were formed north of this big sand ridge, sand ridge. So we've got the one right here, and we got another one right here. So the Alfred is right here, Plantagenet is right here, Curran is right here, and Saint Pascal is right here, just for reference. After that, you see another type of sand, the more recent type of sand, when the delta was a lower output, so less flow. So you can see right here sandy ridges forming the Mer Bleue bog. You can see a sandy ridge right here. Here, this is Bourget, right here. So it's on a very long sandy ridge. Right here too. This is Bear Brook, coming into South Nation, and we also see a little bit right here, close to Curran. You see here in Alfred, which is lying on the more recent sand dune, and we see some right here and here, close to Hawkesbury. So that's it for the sand. In the blue that takes over most of the space, this is clay that was deposited during the Champlain Sea. So we got two different types of clay. We got sandy clay right here on the north side, on the south side of the Ottawa Delta. So the current has not affected the clay as much, so it hasn't stripped the sand from the clay. So there's still some sand, but it's still very swampy because of the underlying clay. And then you have here, and then you have the island here, which is Orleans. You've got Navan, you've got Sarsfield, and you've got Cumberland right here. So the areas that were affected by the Ottawa Delta, the sand was stripped. The clay also was stripped a little bit, so there's no sand left, and it's mostly just Letta clay. So Champlain Sea clay. Marine clay has a very interesting bond. So it's held together as a unit by the salt in it, by the ion. So when water goes through it, it has the possibility of washing away the salt and basically collapsing the bond that holds the clay together. So this is called liquefaction, and it's very common in Eastern Ontario. So all the red that you see are old landslide, paleo landslides. It happened a few thousand years ago, and there's quite a few of them on the Quebec side too, but most of them are on the Ontario side. So this is Clarence Rockland right here. You see massive landslide. These were dated, and they apparently all happened at the same time, about 4,500 years ago. So they would have been caused mostly by, probably by an earthquake, because of the fact that they were all dated at the same time. So the way these were dated is you find trees or vegetation that was buried by the landslide, and you date it, you carbon date it, so that you can have a pretty exact idea of when the landslide happened. So these were all, those are all 4,500 years old. It must have been quite the site, because these are absolutely massive. So you can see Bourget is right here. You can see Clarence Creek right here, and you can see Rockland right here. So these, just to give you an idea of how big these are. And then you got these guys right here. So this is Lac Georges, north of Alfred and close to Lefebvre. This is Lefebvre right here. And this massive landslide was caused by an earthquake 7,000 years ago. And it goes north of the river as well. So you can see right here. So this would have blocked the river essentially. So this would have caused massive flooding of the South Nation and the old Ottawa River Delta. Like I said, it would have been quite a sight as well. So 7,000 years ago right here, which is absolutely massive. You got Baie des Ataka right here. You got Ataka Creek. This is Alfred and the fire, just to give you an idea of how massive this would have been. And Wendover is right here, so a big part of Wendover is also on a landslide right here. Did I miss any type of color? Oh yes, the gray. So we've got the Alfred bog. So this is organic matter. This is the peat bog of Alfred, and then you got Mer Bleu bog right here. Here is called Chalowski Hill, close to Russell, and it's also a lot of organic matter caused by the till that waterlogs. It causes a lot of wetland, and even though it's a hill, apparently there's still a lot of organic matter on top of it. And here we've got the Moose Creek bog, which is the only remaining bog left. So yeah, to give you an idea, this is Clarence Rockland, this is Alfred Plantagenet, this is Champlain, this is Hawkesbury, this is Hawkesbury East. It's about half of it right here. This is the Nation, this is Castleman, and this is Russell Township. So this forms the United Counties of Prescott-Russell. But yeah, the reason why I'm pointing the physiography out, physiography out, is because it's very interesting and it's very unique. It's unlike a lot of the typical watersheds that you would see or think of when you imagine a river. It's very low elevation. There's a bedrock valley, like I've said, the Ottawa embayment, which like I've said, the deepest point of the Ottawa embayment is right here, which coincides with the wetlands, the floodplains of the South Nation. Is Cobbs Lake right here, where it would have been. And there's also another valley right here in Limoges, as you can see right here, which would have been a distributary, just South Indian Creek right here, which during times of flood, it would have filled up, and it would have filled up the swamps right here, and then it would have gone to Bear Brook Creek and filled up the wetlands here too, and then emptied into Cobbs Lake and the floodplains, which eventually would have made their way to the Alfred Bog right here. It would have filled up during the floodplains because it was connected to the wetlands. It filtered the water, held up the water during the dry season, and emptied it back into the South Nation River and into Attica Bay on the other side in Attica Creek. This we know for a fact because Caledonia Spring, which is right here, the sources were commercialized in the 1800s, but these sources, basically like I'm telling you, is the water coming in from the South Nation, water coming in from Van Cleet Hill, water coming in from the Saint Isidore and Scotch River, Riceville area. So a lot of different flow of water, and they all coalesce more or less in the Alfred Bog, which goes to show the importance of the wetland, the historical importance of the wetland for the South Nation watershed. But yeah, this is a more or less a physiographic map of what it would look like. So everything that is on clay right here would have been wetlands. The entire Castell River would have been wetlands. So this was dug. In today's cost, it would have been a few $1,000,000. This was dug as a channel to stop all the wetlands and the water going through and seeping through the South Indian Creek. And then on the other side of Chilosky Hill, just past Russell, north of Russell, there would have been big wetlands as well that would have emptied, half would have emptied into the Mile Bleu Bog and Bear Brook, and half would have emptied into Castell River. But because this area is now owned by the city of Ottawa, it's being heavily developed. So a lot of changes to the hydrology right here, which causes a lot of flooding in Prescott-Russell. And this is more or less the practice for every other municipality upstream of Prescott-Russell, which is a lot of water mismanagement that causes more problems in our townships than they would in their townships, because as we know, water flows downhill, water flows downriver. And it so happens that Alfred Plantagenet has all that river and all that pollution coming through, which is not good for the environment and not good for the quality of life as well, which goes hand in hand with the environment. But yeah, this is what I wanted to show you today. There will be more to come. This is just like a test run of recording my screen and recording the maps that I've made and the maps that I've researched and found about Prescott-Russell and Eastern Ontario, to give you an idea more or less of what's happening, what's going on in the region. So you have a nice day. Oh, and Merry Christmas.